morning and welcome to Radio Friends on Thursday, January the 19th. We've got two almost space travelers with us today. Back once again, Melanie Knocke, good to have you here. Columbia Public Schools Planetarium, and Rex Beltz, a science teacher at Columbia Public Schools, actually Rockridge, right?
Yes.
And both of you did a trip of a lifetime not very long ago, going out to California and flying on SOFIA, that modified Boeing 747. And we're looking at that in the studio right now, the picture of SOFIA, which is part of NASA.
Right.
And you had wonderful story coverage in the newspaper and on here, and I'm excited for you. And the excitement continues because you're taking it to the community.
Right.
Finally, in a couple of days, right?
We are going to be talking at Saturday Morning Science on Saturday, January 28th. It's the first of this season science talks on Saturday
Since you've
mornings.
come back from the
Since we've
trip.
come back from the trip, right.
So when people come out to this on Saturday, what can they expect to learn and see?
So we'll talk a little bit about the history of SOFIA, why we use flying observatories versus land-based observatories or space-based observatories. We'll talk about infrared, the electromagnetic spectrum.
Right, the who, what, why of SOFIA. And, you know, we want to show people why it's relevant to our lives, not just how Rex and Melanie got to have a really awesome adventure.
Right.
Okay, you know, that was part of it. But, you know, there's a place in our world for observations such as these.
Exactly, because so much has been learned from going to the moon, orbiting the Earth. When you think about, correct me if I'm wrong, but memory foam, the reason we have memory foam is because of the Apollo
astronauts.
The Apollo astronauts, right.
Yeah.
So if you sleep on memory foam at night, you can say thank you to the space program for that.
And so you never know what is going to come out of exploring and pushing the edge of the envelope. And SOFIA is a 40-year-old aircraft, but it has a 100-inch telescope on it, which is another huge complication. And they have cutting-edge detectors that they are constantly upgrading, which is one benefit of having an instrument on SOFIA versus a satellite. If you launch a satellite into space, it's gone. You can't touch it.
Right.
The Hubble Space Telescope, they launched it into space, but kept it in low Earth orbit so that we could touch it with the telescope.
We could repair it, upgrade it.
With the space shuttle, right.
Mm-hmm.
The space shuttle's gone, so once the Hubble dies, it's dead. But with SOFIA, because it's on an aircraft that we can take off and land, we can make adjustments to the instruments.
Right, and you fly high enough altitude that you're past most of the atmosphere and the pollution.
99.8%?
99.8%, right, of the water vapor in our air, which is important because we are talking about infrared astronomy versus regular astronomy.
Okay, let's explain what infrared astronomy is.
So we have the electromagnetic spectrum, which goes all the way from radio waves all the way to gamma rays. And you have all these different wavelengths of energy, but they're all light. But as human beings, we can only see a narrow slice of optical light. And there's so much more information, so much more knowledge we can gather from the universe if we use beyond that narrow slice that our bodies allow us to see.
And we just have different ways of detecting these types of radiations. I mean, you can't see radio waves. That's why we have ears. We have ears to detect radio waves.
Right. Well, you can't see. There are television waves coming all through here.
Right.
We can't pick it up. You have to have a special instrument to pick it up.
Right. And with infrared, it is just beyond the capabilities of the eyes to detect it. That we feel it as heat. Okay, so that is the infrared radiation that we are looking for with SOFIA, and they had to put it on an airplane because most of the infrared radiation from space is absorbed by water vapor in our atmosphere, which is why we have to take it above the atmosphere.
So what is being learned? What are you learning from looking at infrared?
Well, okay, on the flights that we took, they spent a lot of time looking at clouds of molecular hydrogen and studying them to see how those clouds were collapsing and cooling off, because we think stars are formed by a collapsing cloud of hydrogen gas. But there's a trick to it. If the cloud collapses too quickly, then it will heat up and start expanding again, and the collapse will stop and no stars will be formed. But for some reason, sometimes the cloud collapses and manages to cool off and keep collapsing to the point where it gets dense enough and the pressure is great enough and you have star formation. And so with SOFIA, on the nights that we were observing, they were looking for a particular cooling line of carbon. And if they detected that, they think that is a byproduct of a certain chemical reaction. Is that right? Chemical reaction on how the cloud is managing to cool off and to continue to collapse, which triggers star formation. What do we care? Well, our star is the sun. The more we know about our star, the more we know about stars in general, gives us a better understanding of the solar system that we live in.
Right. And so, and also to address your question, why do we do this? My kids sometimes in class will say, why do we need to learn this, Mr. Beltz? And that goes back to the classic, what's over the horizon? I think there's something innate in all human beings to always explore and to seek out those questions that, we don't have the answers for right away. And SOFIA was the ultimate what's over the horizon experience.
Because you never know. You never know what you're going to discover and how that discovery is going to change our life or life in the future.
Mm-hmm. And the technology that is required to do these type of things trickles down to us, our cell phones, our small,
exactly.
Yeah, it all trickles down. So we were looking at cutting edge instruments and, like nanowire detectors, which if you come to the Saturday Morning Science, we have pictures. We have a great scale. We have a 100-inch diameter ring to show you the scale of the telescope, and then we have a picture of the holder for the nanowire detector. So you've got 100 inches of a mirror and a nanowire detector.
And so much of this has come from the space program.
Exactly.
So much. So when you hear somebody say, why do we have to spend all that money to go to the moon or go to outer space? Just remember, so many of the things that we enjoy here on Earth and that we take for granted every day would not be here if it were not for the scientific exploration of the space program.
Exactly. So we're going to be talking on Saturday the 28th at 10:30 at the Monsanto Auditorium at the Bond Life Science Centers on MU campus.
And everybody is invited to attend.
Everybody is invited to attend. Yeah, carbohydrates and coffee are free.
Carbohydrates and coffee.
Yeah,
free.
yeah, donuts and
okay.
Bagels.
Yeah. All right. Thank you so much for coming by. Always a pleasure to have you here.
Thank you so much.
Okay, out of time for today. Tomorrow, we got Jack Schultz on from the MU Life Science Center.
Oh, okay.
All right. Well, perfect. Just fits right in there. Drop me an email, pepperp@missouri.edu if there's something you'd like to hear or see. Bye-bye.